We're going to spend a few minutes looking at a method to do unit conversions. As a part of our curriculum, you will need to be able to convert to and from centimeters, millimeters, and micrometers. To start out though, we're going to use units of money because we are all most familiar with that. I'm going to recommend that you grab a pen and a piece of paper because you're going to be jotting down some notes and practicing some calculations. Additionally, you can find a final copy of this presentation at hallockscience.com on the Study Guides tab. Just be aware that you're going to have to complete a Google form at the end of this lesson so that I know that you viewed the lesson and that you understand what we did here today. Before we get into actually converting our units, I want you to see the differences and similarities between the same value expressed in two different units. We can see here that 2 dimes is equal to 20 pennies. So the value is the same. However, the units are different. In terms of dimes, we have fewer of a larger unit and in terms of pennies, we have more of a smaller unit. However, the value is exactly the same. In our first conversion problem, we're going to look at this one. If Izzy has 2 quarters, how many pennies would Hannah need to have an equal value of money? Most of us can just automatically do it in our heads because we are so familiar with working with money. Of course, we can see that it's 50 pennies. You probably did the calculation automatically, but if you think about your thinking, then you probably said 2 quarters equals 50 cents, which equals 50 pennies. When faced with converting to and from units of measurement that we are not familiar with, we need to think about how we actually do the conversions that we are familiar with. And of course, that's where the formulas come in. So we're going to look at the same problem as though we don't know the answer. What we do know is that 1 quarter equals 25 pennies. We can express this as a conversion factor. We can say that 1 quarter over 25 pennies, or we can say 25 pennies over 1 quarter. We can call these conversion factors because technically they're both equal to 1. So I can multiply anything by this or this, and I'm not changing the value, but I can use it to change the units. A conversion factor is a fraction that is equal to 1 but has different units on the top and bottom. So I've rewritten the problem in the top left-hand corner, and you can see that Izzy has 2 quarters, how many pennies, and I've written our 2 conversion factors in the top right-hand corner, and we know both of these conversion factors are equal to 1. So in order to solve this particular problem, I'm going to take the value that I have, which is 2 quarters, and then I need to pick one of my conversion factors to try and convert to the next unit, which of course is pennies, because that's what we're trying to get to. So I'm going to choose the conversion factor on the right. And after I write the conversion factor there, you're probably going to see why I chose that conversion factor and not the other conversion factor. So technically I'm taking the 2/4 and I'm multiplying them by a value of 1 because the conversion factor that I picked, 25 pennies over 1/4, is equal to 1. By looking at this problem now, you can see that quarters cancels out of the equation. So I'm left basically with 2 times 25 pennies over 1, which is going to equal 50 pennies. So I can see here from solving this problem that 2/4 equals 50 pennies. But we knew that because we did that in our heads. But what I'd like to point out again is the difference between the units. In terms of quarters, I have fewer of a larger unit, and in terms of pennies, I have more of a smaller unit, but the value is exactly the same. So you're probably asking yourself, how did I know which conversion factor to use? And the answer is that I use the converting units formula, which is kind of a silly formula, but it's a formula nonetheless. In this formula, when we have to convert units, we start with the units we have, and we multiply by the units we want over the units we have. So I knew which conversion factor I wanted to use because I knew that I wanted the units I have to cancel, and I wanted to be left with the units we want at the end of the problem. So if we use this formula plus a conversion factor, we can convert units. So we're going to practice this a few more times. So in this next problem, we see that Sam has 16 dimes and Carter wants an equal value of money in nickels. How many nickels does he need? You can probably do this one in your head as well, but we're going to do it using our formula and a conversion factor so that you can practice using this method so that you know how to do it when we transfer over to metric system and converting from centimeters to millimeters to micrometers. We know that one dime equals 2 nickels. So from here, we can create 2 conversion factors. I can say 1 dime over 2 nickels, or I can say 2 nickels over 1 dime. I also know that I want to use the formula units I have times units I want over units I have. I do this so that I can get those units I have to cancel out of the equation at the end. And I'm left with the units I want. So I've rewritten all the information on this page. I have my problem, I have the conversion factors, and I have the formula. So what I have is 16 dimes. So I'm going to write 16 dimes here. And I want to multiply that by what I want over what I have. So I want nickels, and I want nickels to be on the top. So I'm going to choose this conversion factor because nickels is on the top, and that's the value I want to end up with. And dimes is on the bottom, and that's the value that I want to have cancel out of the equation. So my dimes cancel, and I'm left with 16 times 2 nickels. And there is a 1 under here, but he just gets divided in and goes away anyway. And we end up with 32 nickels. And I just want to compare or reinforce this concept that even though the units are different from dimes to nickels, the very fact of the matter is that 16 dimes and 32 nickels is exactly the same. We have more of a smaller unit and fewer of the larger unit, but the value is exactly the same. So hopefully at this point you're getting pretty comfortable with this idea of a conversion factor being equal to 1, so I can multiply it into an equation to change units, and it doesn't change the value. And you're getting comfortable with this formula, what I have times what I want over what I have, and that's what we use to convert factors. So on the next problem, I'm going to give you a few seconds alone to work it out, and then we'll go over it together. And then we're going to convert this or transfer this over to working in the metric system. So in this problem, we're going to imagine that Amy has 15 nickels and Larry wants an equal value of money in quarters. How many quarters will Larry need? So what I want you to do right now is write down, we know that blank quarter equals blank nickels. You're going to fill in the blanks. And hopefully you wrote in that 1 quarter equals 5 nickels. Your next step now is to create 2 conversion factors. So I'm going to write this here, conversion factors, and remember those are fractions that are equal to 1 with different units on the top and the bottom. So from this information, we can create 2 conversion factors. So I'm going to give you a second to do that, or 7 seconds. And hopefully what you wrote was 1 quarter over 5 nickels, or 5 nickels over 1 quarter. And next, I would like for you to write down the formula that we use when we want to convert from one unit to another. And you should have written what I have times what I want over what I have. I guess we could say instead of what, we could say units I have times units I want over units I have. That would be better. So actually, I should probably go back and rewrite that as units I have times units I want over units I have. So at this point we have all the information we need to be able to solve this problem. So I'm just going to go on to the next page and we'll just jot our little summary down. So I'm just going to give you about 30 seconds or so to fill in this formula and to pick the right conversion factor and to solve that. You can pause the video if you need a few more seconds. But from here, the units I have are 15 nickels. We're going to multiply that by the units I want. I'm looking for quarters on the top, so I'm going to use this conversion factor. And when I multiply this across, well, first of all, I'm going to cancel out those nickels because they can go away. And when I multiply across, I'm going to see that I have 15 quarters over 5, and the nickels is gone. And when I do that division, I end up with 3 quarters, which is equivalent to the 15 nickels that I started with. And just to reinforce again, we have fewer of the larger unit and more of the smaller unit, but the value is exactly the same. So this process that we're using actually has a really big name. It's called dimensional analysis, and we're using conversion factors. The reason I'm teaching you to convert using this method is because when you get to chemistry next year, you're going to be using this method a lot. So this is a little pre-introduction to that method. Plus, we're going to be using the method in class over the next few weeks to be able to convert between centimeters, millimeters, and micrometers. And I want you to really understand what you're doing when you do those conversions. So the 3 units that we're really worried about in living environment is centimeters, millimeters, and micrometers. And we're going to be using these units as we estimate the sizes of organisms inside a microscope. So each of these has an abbreviation, and I'm sure you're familiar with centimeters. Those are cm. I'm almost positive you're familiar with millimeters, and those are mm. And micrometers you may not be familiar with, and they're abbreviated as this symbol. This guy's name, he's actually a Greek letter, or a Latin Greek letter, I think. And it's the Greek letter mu, and he's written like with a long tail and a U like that. So those are micrometers. And we're going to be using these 3 units, and you're going to have to be able to convert between them. The conversion factors you may be familiar with, or you're definitely familiar with the fact that 1 centimeter equals 10 millimeters. And from that, we can create 2 conversion factors, and that would be 1 centimeter over 10 millimeters, or 10 millimeters over 1 centimeter. The other thing we know, and conversion factors can all be looked up, this is not really something you have to memorize, but when you're using them really frequently, typically you will get used to using them. I'm just going to erase my mu stuff over here. Don't need that anymore. Okay. So back to the pen. The other thing is that 1 millimeter is equivalent to 1,000 micrometers. So micrometers are actually a very small unit. And if I go ahead and write out those conversion factors, it's 1 millimeter over 1,000 micrometers, or 1,000 micrometers over 1 millimeter. So these are the conversion factors that we're going to be using as we convert from centimeters to millimeters, or from millimeters to micrometers, or going back the other way. So all of these are considered to be conversion factors because they are equal to 1, but they have different units on the top and the bottom, and we're going to use them to convert from one unit to another. So in our first problem with the conversion between centimeters, millimeters, and micrometers, we're going to look at this. Jane measured a pen to be 140 millimeters. How many centimeters would this be? So we know that one centimeter equals 10 millimeters. And we can create two conversion factors from that. Oops, that's not right. 2 millimeters, or 10 millimeters over 1 centimeter. So I know also that I want to use the units I have and multiply by the units I want over the units I have. And when I start filling in the blanks, the units I have is 140 millimeters. So this is 140 millimeters. And I multiply that by the units I want. It's asking me for centimeters. So I'm going to choose this one because centimeters is on the top. And when I do that across, I'm going to, first thing I want to do is cancel out these millimeters. We don't need those guys. I'm going to multiply across the top 140 centimeters over 10, and there's no unit down there anymore, and when I do that I come up with 14 centimeters. 14 centimeters is equivalent to the 140 millimeters. Same value, fewer of the larger unit, more of the smaller unit, but the same value. And we've just converted from centimeters to millimeters. So we're going to look at one more problem. I'm going to give you a few seconds to do this one on your own and then fill in the answers. And then you'll have one more problem to do completely on your own, and you'll put the answer in the Google form. So for this one, Harvey is looking through a microscope and sees an organism that he estimates to be 0.5 millimeters. How many micrometers would that be? So the first thing we know is that 1 millimeter equals 1,000 micrometers. So from here, you should be able to write two conversion factors. So I'm going to give you a few seconds to do that. And you should have written 1 millimeter over 1,000 micrometers, or 1,000 micrometers over 1 millimeter. Both fractions represent 1, so we can use them to do the conversion. And the next thing I want you to do is write the formula that we use to do the conversion. And that formula is units I have times units I want over units I have. So on the next page, well, I'm just going to shorthand this now. At this point, I'm starting with 0.5 millimeters, and I want to go into micrometers, so I'm going to use this conversion factor on the next page. Hopefully I can remember to do this. So it's going to be 0.5 millimeters times 1,000 micrometers over 1 millimeter, and I'm going to have the millimeters are going to cancel, out they go, and 0.5 times 1,000 is equal to 500 micrometers. And I can see that compared to my 0.5 millimeters that the value is the same, but the units are different. I have more of a smaller unit and fewer of a larger unit. Okay, the next problem is going to be for you to solve completely on your own. I'm going to give you the we know that, and then you're going to do the rest. So here's your last problem. Billy's teacher said that the average size of an amoeba is 300 micrometers. How many millimeters is that? And we know that 1 millimeter equals 1,000 micrometers. So you'll have to figure out what your conversion factors are. You're going to have to use the formula to solve for millimeters. And when you're finished, you need to go to the Google form at hallockscience.com and complete the 5 questions on the Google form, and I'll see you tomorrow.